Greetings, everyone. I'm Ian McCarthy of Lifting for Life and No Bullshit Bodybuilding, and I'm here once again with Menno Henselmans of Bayesian Bodybuilding. It's been a couple of years since we've had a discussion, recorded discussion anyway. You appear to have survived the intervening period. Menno is here today to discuss protein intake, metabolic damage, and training frequency. So, Menno, thank you for coming back. And I'm not... As a consumer of content, I'm not a huge fan of long introductions, so I'm hoping you can open with a summary of what it is you actually think about protein intake, as I've noticed some commentary on social media lately to the effect that people think that you just think 1.8 grams per kilo of body weight per day, and that's the end of the discussion. Mm-hmm. And I want to be sure that we actually know what it is you think.
I think that for the vast majority of individuals, 1.8 gram per kilogram total body weight, total protein, covers all requirements and is sufficient to maximize muscle growth. But there are certainly several factors that influence how much protein you actually need, and it's very important to establish that the 1.8 figure is basically a minimum. So I don't tell people it's 1.8, and if you consume 1.9, all your gains are down the drain. Mm-hmm. So, in practice, when people say, 1.8 it's far too little, and I recommend 1.8 to 2.7, mm-hmm. that range. Well, in practice, that often ends up being the exact same thing.
Right.
So, if we can go into the factors or...
Absolutely. Well,
sure.
One initial question is, why would you not recommend a range? Because I was rereading the debate that you had with Eric Helms last night. I mean, you had the debate last year, but I was reading it last night, and I will link it in the description box below. I encourage everyone to go and read it. And a point he made that I found very compelling is there's such inter-individual variability here that it makes sense to assign a range, because I know that he's referred to a couple of case studies, which were nitrogen balance case studies, to my knowledge, which I know that you're not a tremendous fan of that method as a determinant of protein intake. But he talked about how there are contexts in which people are eating very high amounts of protein and they're still in negative nitrogen balance. And that at least suggests that we need to give people a range for their intake rather than just saying, this is the singular number which consistently comes out in the literature.
Yeah, I don't think it makes sense to recommend a range to individuals in that case, because you would want to predict where they fall in the range in a population, but for the individual, you still want to give them a concrete minimum number. Mm-hmm. And the 1.8 figure actually already takes into account inter-individual variability, because the actual figure is 1.6, which is the figure that no controlled study has ever found benefits of in terms of strength for muscle growth above that intake. And then what Lemon did in 1998, I think, he added 2 standard deviations to that number to basically account for the inter-individual variability in protein requirements. And that's how he came to the 1.8 figure. And basically all subsequent research has supported that. So that's what I hold. But in terms of the nitrogen balance research, it's a fallacy to assume that negative nitrogen balance, not even touching on the subject of extrapolating negative protein balance from negative nitrogen balance, but let's just assume that that is the case. Mm-hmm. That means that someone needs more protein, because you can be in negative nitrogen balance because you're ill, because your training program just sucks, because your deficit is too large, or for a multitude of reasons.
That was questionable lighting.
Right.
I'm not that pale.
You were a bit paley white. But what was I saying? Yes. So negative nitrogen balance, negative protein balance doesn't mean that someone needs more protein. That's actually circular reasoning, because you assume that protein increases protein balance, and then you say because someone is in negative protein balance, you should increase protein needs. But the reason that they are in negative nitrogen balance can be a host of different things, not necessarily protein. So the question is always only, is one protein intake superior to another, and you can't infer protein requirements from someone's state of nitrogen balance.
Right. What you discussed in the debate is that you would need something to which to compare it, right? In order to conclude that negative nitrogen balance is indicative of insufficient protein.
Yes.
So you talk about 1.8 grams per kilo as a minimum, and I think that someone like Eric would largely agree with that. And you talk about wanting to find the appropriate intake for the individual. So assuming you don't know the individual, what is the issue with giving a range, knowing that the vast majority of people in that particular context, you would assign a range for lean individual and a deficit, etc., would land in that range? Do you simply think there isn't enough evidence, whether that be scientific or anecdotal or combined, to give a range reasonably?
No, I think it can make perfect sense. And in fact, in many of my programs, I give error margins for the macronutrients, including protein. So it basically ends up being a range. But the only concrete difference between recommending a concrete minimum protein intake and establishing a range is that the range recommends not only the minimum, but also incorporates a maximum. And that's trickier because especially if you use a range of 1.8 to 2.7 grams per kilo, or 2 to 3, which last time I met Eric was the range that he generally uses for total body weight, or lean body mass.
Lean body mass, yeah.
Yeah. So you also establish a maximum, and whether that's needed is a different matter, because I can imagine many scenarios where I actually wouldn't see any downside of going 100% over someone's protein intake. So in that case, my recommendation would actually result in higher protein intakes than the recommendation of a range.
Right. So do you have clients going 3.3 grams per kilo? Obviously, that's a number I just plucked out of thin air, but higher than the top ends of those ranges.
Not often, at least not my natural clients. So I think maybe, the occasional day you might see it in someone's meal plan when they go to a buffet or something. Mm-hmm. But, as a weekly average or something, I don't think any of my current clients come near that level.
All right. So a question that occurs to me is, first of all, it seems that I quite misunderstood your views on this, truthfully, and I really appreciate the clarification. And a question which arises is, what was the intent of your original article on protein? Was that written in 2011 or 2012? The myth of 1 gram. You don't recall? It's been too long.
No, it's one of my first articles. I don't even know anymore.
What was the thought behind arguing that 1 gram per pound is a myth?
Well, it is basically as a minimum or a target intake. But the 1 gram, a lot of people were recommending intakes way higher than that. Mm-hmm. And some people still are, but I think the evidence-based fitness industry, at least evidence-based community, has shifted a lot towards lower protein intakes. I know Eric himself even has. So, that was basically just a catchy title and something to get people's attention. The 1 gram per pound is like the most often heard recommendation, and if you can establish that is a myth, then it's just a good introduction for the article. Because, like I said, the intuition was basically not to go from any traditional recommendation or any other recommendation that was currently or contemporarily being used, and instead just go with what the hard data at that time was showing and establish a protein intake based on that. So it's not, the 1 gram per pound is just one figure, one recommendation that I wanted to show wasn't supported by evidence, but was just a tradition. And it's mainly difference with the higher protein intakes that differs most from my experience. But even the 1 gram per pound, a lot of people say, what's the the problem with 1 gram per pound,
Right.
if you're going to recommend something so close to it, well, my reply to that is, why recommend 1 gram per pound if people don't need it? And it might seem easy, for us strength trainees, that getting 1.8 gram per kilo, especially if you're used to the bro era, which I was as well, then getting that kind of protein in is just way too easy. You don't have to put any effort into your diet to reach that level. Mm-hmm. But really, if you're a coach and you also coach novices, then you'll see that it does take effort to reach that level, especially so for vegetarians and vegans, but even for most novice lifters. You also see this in the literature, which is probably the reason that, interestingly, we do have a few studies showing negative effects of higher protein intakes compared to more moderate protein intakes, significantly, because it's probably just a pain in the ass for these people to suddenly double or triple their protein intake. I was just talking to a relative, and I basically calculated that person's protein intake, and it came out to something like 40 grams a day, because it was a pure carb-based diet, just grains. Mm-hmm. So for that kind of person, that a 20, 30 gram difference in protein intake actually matters a lot. Mm-hmm. And knowing that you don't have to go to that extra level is actually very useful for these people. And it's also very useful during ketogenic dieting, for example, when it can actually be problematic to reach your protein intake, and knowing that you don't have to go that high puts things like cheese, for example, as viable protein sources. Whereas mostly for us, that would be just too caloric to fit into your macros. Moreover, the whole reason that we think it's so easy to consume 1.8 gram per kilos is because our whole mindset is focused on protein. If and I have this too. If we go out eating somewhere, a social eating event, or you have a meal coming up to your next meal, or if it's during a trip or whatever, what's the first thing you think of? How do I get my protein in? So, saying that it's all that easy, and you don't need to worry about the fuzzy details is kind of skewed, because it's the first thing we think of. So obviously it does require a great deal of attention. It's just that we are so accustomed to it that we're no longer actively conscious that we are so focused, not to say obsessed, with protein. I mean, protein powder, protein cookies, protein bars, protein everything. Mm-hmm. And one of the best ways to advertise a recipe in fitness industry is call it high protein this. And then we think it's awesome. If it was really that easy to get your protein in, then high protein should just be attacked like, who cares? High protein. We're already going high protein.
Mm-hmm. So the typical defense I've seen of the 1 gram per pound is simplicity. Particularly, let's say you take someone off the street, they know practically nothing about nutrition, but they're able to look at a box of protein chips, a bag of protein chips, and discern that it has so many grams of protein. And if you tell them, okay, just get your body weight and that's what you eat in protein, it's that simple. So your response is, that's too high, they're not going to be able to do that. And a feeling I've had, and I'm curious to know if you agree, is it seems a bit condescending to imply that folks wouldn't be able to change that number and if they have to, just run it through a calculator and get a lower figure.
Mm-hmm. It's condescending to recommend the 1 gram per pound, or?
Well, yeah, because the implication seems to be, well, people wouldn't be able to figure it out if it's 0.82, or let alone they have to figure out what their body weight is in kilos.
Absolutely. So two things, basically. For one, that kind of thinking is restricted to Americans, because it's 2.2 for people in the majority of the world, mm-hmm. which means that it's really not that simple. And secondly, if you're too lazy to do literally one calculation to establish a minimum protein intake, I can't imagine that person tracking their macros. How is that person ever going to work with calories, fat, carbohydrates, looking at ratios? It's not going to happen. Mm-hmm. If you can't do that one simple calculation, or if your coach can't, or whatever, you can't set up your diet that way, you're pretty much lost.
Absolutely. Well, moving back in the direction of protein intake for really the debate is primarily surrounding lean, muscular individuals in an energy deficit, because Eric actually wrote about this extensively, gosh, it must have been a couple of years now, but this debate about protein has really kind of been ongoing for about 4 years. And I recall him writing something to the effect that, okay, if you have someone who, kind of lifts recreationally, they're trying to gain some muscle, gain some strength, but they're not really lean, they're not trying to get shredded, then yeah, I really don't have an issue with 1.8 grams per kilo vast majority of the time. And I could totally be slightly misrepresenting what he said just due to the time, but that was roughly what he said. So, again, in the context of folks in a deficit, two thoughts struck me. One is, Eric described his approach to this as more conservative than yours, and I certainly see where he's coming from in that in my mind, his perspective is a little more nuanced, willing to open it up more, willing to assign quite large ranges. But I wonder if you're actually being more conservative on this, in that you're the one who's saying, okay, we do have these studies which perhaps suggest benefits to higher intakes, but frankly, those are not good enough for me. I mean, first of all, would you say that's an accurate summary of your views, that some of these studies that, again, suggest benefits to higher intakes, they just don't cut it?
Well, we can go into those studies if you want, because it's a couple lines of evidence. But yeah, the main point is that I just did a rough count before this interview, because in my PT course, I literally have tables with every study on protein intake, and I counted 44 studies. 44 studies that compared different protein intakes and found no benefits of more than 1.6 gram per kilos. So it's not the case that, one study says there are benefits and one study says there aren't. It's the case that we have a vast body of literature that demonstrates no benefits, and there are a few methodologically questionable lines of evidence possibly suggesting benefits of more. But yeah, basically that is my view.
So given your Bayesian philosophy, and I'll back up a little bit, in my experience, Eric is generally a little more conservative, more in the camp of what you've described as those who look for scientific consensus. As an example, Eric typically recommends 2 times a week or 3 times a week training frequency, which, just a few years ago was quite an aggressive recommendation, because, we didn't even really talk about an evidence-based community at that point. Even that language has only really become popular over the past couple of years, but he's recommending that because that's what we see being compared in training frequency literature. So my thought with regard to protein, trying to make an analogy to training frequency, is I wonder why you aren't the person saying, given my Bayesian philosophy of following the evidence where it leads, even if it's weak evidence, why you aren't the person saying, hey, maybe we should be pushing this up because, Jose Antonio's research suggests that people just can't even eat these high intakes, which would imply a satiating effect of protein. Eric's study, which really he argued, and I would agree, was too short to tell you much in terms of strength and body composition changes, but suggested benefits in terms of dietary satisfaction. Why is it's Eric saying, okay, maybe we need to go higher, and not you, given what I think is a difference in philosophy in terms of how you handle evidence?
Right. I would say that in this case, the difference in what you would describe as conservative depends on your original viewpoint. In terms of evidence, I am more conservative. I'm the one that basically says, the evidence isn't strong enough to make a recommendation for more. But in terms of being conservative and more like, right wing, focused on tradition, in that case, Eric is definitely the one that's more conservative, because actually I recall him after his review, he basically decreased his protein requirements after that review. So he's basically coming from traditionally even higher intakes and has adjusted it down, but not as much, not so much that we're now at the same level though. It's relatively minor difference, you could argue. I think that is the main reason, but why not more? I think it's best we actually go into those lines of evidence. You mentioned too, like Jose Antonio's work. That's actually a good one, because if you look at satisfaction with the diet, then a lot of these people, there was a high dropout rate in one of his studies even, and a lot of the subjects complained of stomach problems, digestive issues, and overall just not feeling well. So I wouldn't even go so far as to say that it's really evidence of a satiating effect, but more just kind of the dried chicken breast. Dried chicken breast isn't that satiating. It's just a pain in the ass to eat. It really sucks to eat. It makes you want to stop eating. It doesn't really satisfy you. Mm-hmm. So because if you add some taste to chicken breast, then you actually eat more of it. So it's not a physiological effect of the chicken breast that makes it so satiating, or the protein intake. It's just that it's disgusting. So I call this strategy keeping it bro in terms of appetite management, because it can be useful, especially during contest prep, where you basically consciously avoid eating tasteful food, and your mindset is just food is fuel. During this period, I give up the joys of tasteful eating, and in return for that, I don't have to worry about satiety and my diet. I just don't think about it. I'm just going to do this competition, and afterwards I'm going to eat tasty stuff again. Mm-hmm. But as a long-term lifestyle, I don't think that, from a hedonistic perspective, that can be argued to maximize well-being in life. The other line of evidence you mentioned, another thing about the Antonio studies is that these were entirely uncontrolled studies. There were no protein intake prescriptions. It was just basically try to consume this amount of protein, or here's a lot of supplements, and they saw where they ended up. What a lot of people don't realize is that we have very good metabolic ward research from Bray et al. That looked at the effects of different protein intakes and found no benefits of higher protein intakes, basically finding that higher protein intakes, given the same amount of calories during overeating periods, result in just as much fat gain as more moderate protein intakes. So this idea that the protein doesn't count as energy or something, it does.
Right, because I recall it was one of the two Antonio studies. I think it was the 4.4 gram per kilo, which showed significantly greater fat loss. And I think your response was, well, they just weren't even eating that.
Yeah, exactly. Because if you look at dropouts and a lot of subjects complaining, self-reported data, you really can't make a strong case that they were actually eating that amount. If you're familiar with the literature on the accuracy of self-reported data in research settings, then it's abysmal. You're not looking at small deviations. You're looking at people going 2 to 3-fold over their caloric intake. Usually it's over, but it goes both ways. So it's not the case that they're on average they tend to be accurate, but there are deviations. It's like there are gross systematic fallacies in how people report self-report their macros.
And in the case of these very high protein intake studies, they're going to overreport. Well, I think they would overreport both protein and calories.
I think so, because they basically, it's also very tempting to report that you consumed that protein, even though you hadn't, especially if you end up, already nauseous after your protein shake and you already logged the meal, but you forget not to log it. A lot of things. You could speculate it on a lot of ways, but the point is that it's not going to be reliable data.
So you aren't moved by those two studies in particular at all?
If those were the only two studies, I'd be very moved. But given that we have an earlier study from, I don't know who it was, but it was a very same setup, and the metabolic ward research, which is like the most controlled research we have, showing no benefits of the higher protein intakes in terms of fat loss or preventing fat gain during overeating, then I think we have to take those self-report data from Antonio's work with a very large grain of salt. Mm-hmm. Moreover, in terms of satiety, it's commonly accepted I'm going to give a few spoilers here, but it's commonly accepted that protein is more satiating than carbs or fat. A lot of people say this.
Right. I was going to ask you about this.
Yeah, it's actually, if you logically think about it, it's nonsense, because if protein is always more satiating than carbs or fat, you would imply that the most satiating diet is basically pure protein. But even if you look at something like chicken breast, which is like the leanest whole food kind of protein you can get your hands on, unless you live in Australia, you can eat kangaroo, certain kinds or something. Then if you compare that to, say, zucchini, you're looking at a 6-fold difference in total food intake. So someone eating 100 grams of chicken breast, which is absolutely nothing, especially after cooking it, and someone eating 600 grams of zucchini. I'm pretty sure the zucchini is going to be more satiating. Mm-hmm. So also because I have experimented with it a lot myself, so it's not speculation. I'm pretty sure that at least for me, this is definitely the case, and a lot of my clients that I trust in this regard in terms of experimentation as well. More importantly, in terms of scientific evidence, there actually currently isn't evidence establishing that more than 1.8 gram per kilogram is more satiating, a higher protein intake than a lower one. Actually, there are a few studies finding no benefits that have looked at higher protein intakes. And then we have Eric Helmsman's study, but this was greatly confounded by the use of, I think it was maltodextrin, or basically some carbohydrate supplement. So you can't say that it's protein that's more satiating than carbs. No, it's just that I think it was pea protein powder, is more satiating than sugar. Well, not too surprising. Sugar doesn't have, basically has a satiety index of 0. It's like as low as it can get. So
well, could I just question you on this briefly? Because in rereading the debate, you brought that up and then Eric responded to it. And if I recall correctly, he cited 5 studies, which, his conclusion was it's unclear really what the role of sugar is here, whereas he thinks it's clear that there's a satiating effect of protein. So he doesn't think that you can conclude as strongly as you did, okay, it's just the maltodextrin, that's the difference. To my knowledge, you didn't respond to that in that context. So what do you feel is the evidential basis for saying, well, sugar easily explains this difference?
Well, for one, logically, that was the comparison. You're looking at the comparison between sugar or whatever it was and pea protein. So you cannot infer anything about macronutrients extrapolated. The study only shows that. That comparison is what they studied. So that comparison is all we can conclude anything about. But secondly, there is a lot of research, like the primary satiety index developed by Holt et al. In 1985. And that shows that like wise bread, and wise bread is actually the reference point as a satiety index of 100, and pretty much every protein source scores more than that. And I think in sugar, it's actually debatable about research. Some research finds that sugar doesn't seem to be that much less satiating than, for example, white bread, but it's pretty clearly established that sugar isn't as satiating as, say, whole grain bread, which generally falls in research and in Holt satiety index far below lean protein sources, or any kind of protein source, basically. So I think there is a lot of scientific basis to conclude that protein sources, in terms of foods, are a lot more satiating than sugar, which means that the comparison doesn't really tell us a lot about protein versus carbs in general.
So what kind of study design would they have had to use for you to find it moving? Would they needed to have had different protein intakes and additionally different energy intakes? I mean, because would they have had to make the only difference protein, which would then entail a difference in energy intake? But then I feel like the objection could be, well, the energy intake isn't the same.
Your video and audio are kind of desynced at the moment, but I did hear you. I can tell you exactly what the design is that I'd like to see, because we are running a study right now, my research team, with that design, which is basically you want to compare different foods, and we are going to compare higher and lower protein. We also did a literature review on it, and we're going to do, if the data allows it, a meta-analysis on it. We're working on it right now, actually, with James Krieger. So you'll see exactly what I'd like to see, and I'm wholly open to being proved wrong. But right now, the evidence is definitely that it's not strong at all for the claim that protein is more satiating than carbs or fat, especially not at a higher level, because at lower levels, we actually have very good theoretical rationale for the satiating effect of protein. This is called protein leverage theory, and it basically states that, kind of like salt, your body responds to protein intake because, unlike carbohydrates in the form of glycogen and fat in the form of adipose tissue, your body doesn't have an effective storage means of protein other than lean body mass, but that's very energy intensive to create. So it wouldn't make a lot of sense to use that as a primary means of storage. And you have the amino acid pool, but that's not very effective or long term. So the theory basically states, and several studies support it, that until you have sufficient protein intake, your body's appetite regulation, the feedback loop, that when you eat, it decreases your appetite, is sensitive to whether you're consuming, you're going to consume enough protein. So if you're only consuming carbohydrates, and especially in animals, we have a lot of very strong data, the animals basically just keep eating until their protein intake is enough. So they're going to keep consuming rice, and they're going to massively overeat until they've consumed enough protein. Mm-hmm. And in terms of human data, the evidence seems to support it, but it's a lot more tricky because what we just talked about, we're bringing back to the methodological problem, the difference in comparing macronutrients and actually comparing foods. So what we're going to do in our study as the basis is to use calories as the main equation point. And we're going to we're going to measure medium and higher protein and have the difference made up of foods that competitors would actually reasonably be thought of to consume as an alternative to protein, like vegetables and actually energy scarce carbohydrate sources, not sugar. And then what we'll see, but I'm very skeptical that protein is going to win out over very low energy dense fibrous food.
You're skeptical of that being the case?
Yeah.
And what are if you don't mind me asking, what are the outcomes you're measuring? Are you only looking at satiety in this case, or are you looking at body composition, strength? Yeah. We're looking at satiety and overall diet satisfaction as well, because that's another thing that I think is very important, at least in my experience, is just not as satisfying. And that's a tricky thing because the research doesn't really support this, but I sort of hold a dual factor view of satiety in that I differentiate between desire to eat and actual satisfaction. I notice that for myself, I can definitely stop having a desire to eat after eating chicken breast, for example, or gherkins are another good example. I really just at some point lose all motivation to continue eating, but I'm not satisfied after the meal. Mm-hmm. So we're going to test that as well and see if we can also maybe do a methodological study on to see if that dual factor view of satiety makes sense. So do you think that if ultimately there's convincing evidence for higher protein intakes, it's going to be in that area as opposed to there's suddenly being new research showing more muscle growth with higher intakes or greater strength gains with higher intakes? Probably, yeah, because like I said, we have so much data already that you'd actually expect the occasional study, because like I said, we have 44 studies, even with an alpha rate, a type 1 error rate of 5%, you would already expect that in the current literature, we'd have 2 studies that found statistically significantly or statistically significant benefits of higher protein intakes for muscle growth or strength development, simply because of the statistical error margin. But we don't see that. So, even if there's now one study that comes out and shows these benefits, it's probably not going to change my recommendations a whole lot, because you're still looking at the whole literature in terms of evidence. But I can share another study that's going to come out. A lot of people, including Eric and me, are involved in a meta-analysis on the effect of protein.
And there's probably going to be another systematic review for my research team that follows it, that has a slightly different methodology. So I'm still wholly open to there being shown that indeed there is a reasonable probability that higher protein intakes have some benefit, which means that I would increase my protein requirements. But I don't think that will happen.
Absolutely. Well, I think that's a good place to stop on that topic, and I'd like to move to metabolic damage. And my feeling is this can be relatively brief, as to a large extent I think the dialogue on this has been exhausted, but I did want to bring it up because I know that you and your colleague, whose name I surely cannot pronounce, are
Anastasia
doing...
Zinchenko.
Excellent. You've done...
You can just call her the Russian.
The Russian. The singular Russian. You've done, is it a meta-analysis or a review on the evidence regarding metabolic damage?
Yeah, that's actually a good point, and that's also what peer review asked us, which is why we had to resubmit it and now have to recategorize the paper, split it into two, and submit it in two different sections, because it was sort of a review, but it wasn't really a systematic review, but it also included original research, because we reanalyzed a lot of data and analyzed some data in aspects that others hadn't done before. So it was kind of a mixed review, original research mix. So it didn't really neatly fall into any established category.
Right. So before we get to that, I first want to ask, how does one best define metabolic damage? And I ask this because in my perception, there's been a slide over the past 4 years or so of this being something anyone talks about, in that when it first came out and there was great controversy surrounding it and so on, it seemed very apparent to me that there was a genuine difference between metabolic adaptation, adaptive thermogenesis that's already very well established, uncontroversial, and metabolic damage. At the very least, this is something beyond the scope of what we've traditionally talked about as metabolic adaptation. And the slide seems to have been toward, it was the same thing all along. So there shouldn't have been this great controversy. It's only a terminological difference. And I'm very unimpressed by this, because I think it was clear that the claims initially are not naturally entailed by metabolic adaptation. And given the, in my perception, lack of evidence for metabolic damage, the response has been, we didn't really mean that anyway. Like, that's not what we meant. We were just talking about what is evidenced. So what definition of metabolic damage did you use in looking at the literature on metabolic adaptation?
Right. I think first, I think it's only natural here to mention Lane Norton, because a lot of people ask me, but Lane said this or this, or what do you think about Lane's claims regarding metabolic damage? I held a debate with him, the reverse diet debate that you are aware of, and we seem to be in agreement there. So I'm literally genuinely not up to date on what Lane currently claims or has claimed before. I do think that there was some genuine misunderstanding on the terminology, but I definitely, we hold in our paper as our view, and what I only logically think is the most reasonable, or reasonably think is a viewpoint that one might take, is that metabolic damage is distinguished, or should be distinguished, from metabolic adaptation, because the word damage implies a lot more. It implies that it's not something that adapts and goes right back to what it was. It implies that something is now wrong and broken and will continue to be broken. So that is basically the definition that we used in our review as, I have mosquitoes, right? As metabolic adaptation during underfeeding that persists after weight regain. So it's adaptation, but adaptation that stays in effect even after you return to your original body composition.
Absolutely. And what did you find with regard to the evidence for or against this existing?
Right. What we did is we analyzed several lines of research, and I'll keep it pretty concise. We looked at Minnesota starvation experiment, which is the classic source of metabolic damage, what a lot of authors have looked at. We used a new model here, actually more than what you saw in the seminar you attended, is that we now analyze the data using 3 different prediction equations for BMR, basal metabolic rate. And we looked at the ratio of predicted basal metabolism, someone's resting energy expenditure, what you would predict from their body composition, and their actual resting metabolic rate. And looked at this ratio over time, and what you see that if there's metabolic adaptation, you see that the ratio decreases. So you find metabolic decreases that are larger than anticipated simply from their loss of weight, because no one in the scientific community at least will argue that your metabolism will decrease with weight loss, or generally does, if you lose tissue, especially if you lose muscle tissue. And if you start eating less, the thermic effect of food decreases. So there are various pathways by which your energy expenditure will decrease. But the question is not, does it decrease? Does it decrease more than you would expect from these things? And the question is, yes, it does. Or the answer is, yes, it does. And that's what we call adaptive thermogenesis. And then the next question is, do these metabolic adaptations persist after return to the original body composition? And then the answer is quite definitely no, what we found. And we looked at data on anorexia nervosa patients. We looked at malnourished populations, experiments like the Minnesota starvation experiment, and a lot of replications like the biosphere experiment that had individuals actually under controlled conditions, starve basically, and come back up to their initial body composition. We also looked at a study on wrestlers going over in and off seasons, and 2 case studies on bodybuilders. And literally every line of evidence that we looked at shows that after you return to your original body composition, your metabolism is exactly as it was before. And there was actually, if there was any trend at all, it was that in a lot of research, metabolism seemed to be higher afterwards, which is kind of curious as well. But our main conclusion was that it's pure adaptation and you can't stop it, and it goes in both directions. So, people like to complain about, well, your body has all these things that fight against you when you're trying to lose fat, but all of these things also help you prevent weight gain, because if you gain fat or you gain weight, then your appetite decreases, your energy expenditure increases. So it's all part of your body's mechanistic pathways that want to maintain homeostasis. So your body has a lot of pathways, a lot of mechanisms that sort of prevent you from changing your body composition. And it goes both ways, and you can't do anything to stop these adaptations, and they are not permanent in any way.
Excellent. One argument I've seen in response is that the mechanisms that resist weight loss are stronger than those which resist weight gain, and that we have this concept of post-diet hyperphagia, people overshooting body fat regain. If I recall correctly, it was the Minnesota starvation study in which the subjects gained back all of their body fat almost immediately, but lean body mass gains were very relatively slow. So would this be justification for the long extended reverse dieting approach that has been advocated by folks like Lane? And I will note that Lane has stated explicitly that in many cases he's more aggressive with ramping up people's calories after shows than he used to be. So I certainly acknowledge that he has changed his views on that.
All right, so a few points. There is indeed an asymmetry in the metabolic, or the magnitude of the adaptations between weight gain and weight loss. So in general you have, but it's not relative to your baseline. It's just that your body basically has a genetic blueprint, it seems, of body fat percentages, and that body fat percentage determines the adjustment. So, which is why after you return to the original body composition, you get the same metabolic rate, if it's at the same fat percentage, right? But at any given fat percentage, if you lose 5 pounds, then the metabolic loss is greater than the metabolic gain than for if you gain 5 pounds. So it's kind of tricky to get your head around, but
yeah, I'm not sure I understand that. It's overly complicated for me.
Yeah, let me see if I can explain it in an easier way. It's just a really tricky concept. It means that the metabolic adaptation is a function of your body fat percentage.
Mm-hmm. So it's better understood as a result of body composition than your diet. So those who say, okay, we're going to seek to increase your metabolic capacity by ramping up your carb intake, the better way to do that is to just be a bigger person.
Exactly. It's your body composition, not your diet. And those two things are very difficult to separate from each other, of course, because your diet influences your body composition. Mm-hmm. But genetically, what your body basically has in mind is your body composition. And energy intake itself does have a separate effect, which is also temporary, but it's separate from the effect of your body composition.
And whether from a scientific perspective or an anecdotal one, do you feel there's justification for the claim that one can increase their metabolism barring changes in body composition?
Right. The only ways that we have any data or plausible mechanism for, in terms of how you can increase your metabolism, is either you gain weight, preferably muscle mass, and even better organ mass, but that's not going to happen, hopefully.
Well, unless you've lost organ mass during dieting.
Yeah, then you do want to regain that. But yeah, you increase the thermic effect of food, which is possible by altering your food choices, but not really. There's a clear limit to it, obviously. Beyond that, you can increase activity level, but other than that, that's basically it. Oh yeah, you could live in a colder environment, which will also increase thermogenesis, heat production, basically.
Excellent.
But yeah, there's no way beyond that to increase your metabolism. I've never seen it in my clients either. And that's actually, in this case, I think that anecdotal data is extremely valuable, because if metabolic damage existed, you would see that every competitor, every contest prep, would lose some metabolism basically and end up with a lower resting energy expenditure than before. And you should see that, a pro competitor who has 20 competitions under his or her belt should have an absolutely abysmal metabolic rate at that point. But we don't see that. And, or at least I hope most people don't. And in my clients, I actually see a trend towards the opposite, which you would expect, because people gain more lean body mass over time and they learn to manage their diet a bit better, fine-tune their rate of weight loss to maintain muscle mass during contest prep, etc., etc. And I basically certainly don't see any trend towards competitors having to go lower and lower in calories every contest prep. Quite the opposite.
I have seen a number of anecdotes to that effect, particularly in the case of female competitors, unsure of why that's the correlation, but who compete over and over and over again every single year, and they diet on, at the very least, they claim to diet on progressively lower calories over time. What do you think is the explanation of that?
Well, I haven't seen those data, but if that were true, then I could see several mechanisms for that, especially when you're looking at, I have to err on the side of caution not to sound sexist here, but female competitors are, in general, in my experience, more likely to suffer from stress, to also suffer more from the hormonal effects of being at a very low body fat percentage, because especially repeat competitors basically will spend very long time periods in amenorrhea. Basically, they lose their menstrual cycle and they compete too frequently to recover it. And in that respect, I'd say it's plausible that over years you indeed basically become simply so unhealthy that it actually affects your hormones and, for example, thyroid hormone as well. So then I could see that effect. I could also see an effect of the chronic stress levels that basically result in burnout, which affects pretty much every system every physiological system that we know of in the body. So I could also see an effect there. But you're looking at very extreme cases, is basically the point, for very high chronic stress or periods of just living a very unhealthy life.
So you could even see cases of, let's say, subclinical or clinical hypothyroidism, but that wouldn't be best accounted for as this is metabolic damage. Rather, you're simply dealing with an unhealthy person, and all of these variables put together have resulted in a genuine medical condition. We're not just talking about their metabolism adapting.
Exactly.
Excellent.
And well, then the question is whether you would call that metabolic damage, but it's certainly not something that's relevant for the average person.
Absolutely. Well, I appreciate the discussion on that. Do you have a few minutes to touch on training frequency?
Yeah, I do. I have 4 minutes because I have another consultation after. If you want to keep it really short, we could do it, but otherwise we can also schedule another.
Absolutely. Let's leave it for another time.
Right.
I really appreciate your time.
My pleasure.
We will talk again. Folks, if you enjoyed the discussion, found it valuable, please make sure to like it, comment below, share it with someone who you think might benefit from it, and feel free to let me know what you think I should interrogate Menno about next time. Thank you so much.